Hello everyone. In this video, we are going to discuss about the interfacing of LM35 temperature sensor with STM32F407VG discovery board. This is the LM35. It consists of 3 pins. VCC pin. This is given to plus 5 volt power supply. Vout pin. This is the analog pin of the LM35. Ground pin. This is given to ground. In this experiment, we will be using STM32F407VG discovery board, LM35 temperature sensor, USB to UART TTL cable, some connecting wires, and breadboard. This is the connection diagram of LM35 with STM32F4 discovery board. First pin is given to plus 5 volt pin of the microcontroller. Second pin, that is Vout pin, which is given to the ADC pin of the microcontroller, that is PA0. And third pin, ground pin, that is given to ground pin of the microcontroller. Here we are using USB to UART TTL cable so that we can print the output in some of the softwares like TerraTerm, RealTerm. TXT of the USB to serial TTL hardware is given to PA3 pin and RxT of the USB to serial TTL hardware is given to PA2 pin. Ground is given to ground. Now, let's discuss the code. Here, we have included some of the header files like string.h, stdio.h, stdin.h, stm32f4xx, hal.h, main.h, and STM32F4XX haldef.h. And then we have declared some of the protocols such as system clock configuration, GPIO init, ADC1 init, UR2 init, and error handler. Coming to system clock configuration. In this function, we have configured the system clock as 84 MHz so that we have given the parameters PLL-M as 8, PLL-N as 84, PLL-P as division 2, PLL-Q as 7, and system clock source as PLL clock, AHP clock divider as division 1, APB clock divider as division 2, APB2 clock divider as division 1. After that, we are configuring the SysTick timer interrupt frequency for every 1 millisecond. Later, configuring the SysTick timer. Now going to GPIO init. Let's discuss about GPIO init. Here, the GPIO initialization function is given. Here, we are enabling the GPIO A clock so that we can use PA0 as my GPIO pin. Coming to ADC1 init. Let's go through the ADC1 init. Here, we are initializing the ADC1 function. Configuring the global features of ADC such as clock, resolution, data alignment, and number conversion is given below. Here, we are giving instance as ADC1, clock prescaler as division 4, resolution as 8-bit, and some of the configuration parameters we have set. And we are using ADC channel 0 After that, let's see the UART2 init. Here we are using UART2 so that we can print over Terra term. Here we are using user2 UART and we are setting the baud rate as 11,000 5200 and word length is 8-bit, stop bits as 1, parity as none, hardware flow control as none, and init mode is TX and RS, oversampling is 16. Coming to main. First I am giving HAL init so that we can initialize the HAL libraries. Then I am calling system clock configuration. I am using 84 MHz as my system clock. Then calling the API GPIO init so that GPIO can be initialized. Then ADC1 init so that we can initialize the ADC1. After that UART2 is initialized so that we can use UART2. Coming to while. First we are starting the ADC. Then we are calling HAL ADC pole for conversion function so that pole for regular conversion is completed. ADC conversion flags such as EOS end of sequence and EOC end of conversion are cleared by this function. Inside this function, we are getting the ADC value and storing into the variable myADC value. Then I am printing the myADC value in UART. HAL UART transmit API is used to send the amount of data in blocking mode. Finally, I am stopping the ADC and I am giving the delay of 1 millisecond. I hope you enjoyed this video. If you have any doubt, you can comment it out. Thank you for watching.